Hi friends, this was the Sudoku that I had put up earlier today, and as I had said that it's an anti-night Sudoku with the central box as the magic square, and I have put CC here, so this is clone 1 and clone 2. These two boxes are clones of each other. These three shaded squares are even digits, and this particular thing is 10. That means these two squares in a cage, the cage was put up like this. These two digits total to 10. So it could be 1 and 9, it could be 4 and 6, it could be 3 and 7. So let's see how to go about this thing in this kind of a Sudoku. Now, what is the magic square? The first thing that we have to do is the magic square. Since we get a central box, it's always easy to then complete the puzzle. The magic square is that all three rows, three columns, this diagonal and this diagonal has to be totaling to the same digit, which I had said would be 15, because the total of 1 to 9 is 45, divided by 3 is 15. Now, there are 9 boxes which total to 45. So 45 divided by 9 is 5. So logically, the central box has to be 5. Now, if the central box is 5, let's see where we can fix up 2 and 8, because 2 and 8 is 10 and 5, 15. So that could be 2 and 8, then 1 and 9, then 6 and 7. Not 6 and 7. It will be, say, 6 and 4 or something like that. What are the variants of totaling to 15? So now let's see where the 2 can go. That's the first thing that we'll have to check. The 2 cannot come here. The 2 cannot come here because of the fact that this 2 looks at this in a knight's form. So the only place that the 2 could go is this, and this. Now this is the way the 2 would go. Now where is that the 8 would go? The 8 cannot come in this box, these two boxes, and it cannot come here. So they can go here, 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 and here. That's where the 8 could go. So we've kept that for the moment pending, in the sense that since the 2 also cannot come here, this is a 2 and 8. The 2 and 8 could be a possibility, 2, 8, 2, 8 in this form. Then 1, 9, 1, 9 in this form. Then 6, 7 maybe, because if this is a 2 and if this is an 8, this cannot be a 2 because of this 2. So if this is an 8 and this is a 2, then the remaining has to be 6 and 7. And then if this is a 2, then what could be what digits could these be? So that is something which we have to figure it out, and let's see how to go about it. But first, before that, the 5 are interesting. The interesting digits are 5. This 5, which goes from here to here. Now, if this 5, there can be a 5 here, here, or here. But if there is a 5 here or here, then the 5 has to be here or here, because these two are clones. Now, because of this 5, the 5s cannot be here or here, so they have to be here and here. And here, this 5 cannot be there because of this 5 seeing in the knight's manner. So therefore, this is a 5 here. That's why this is a 5. Now, this 5 looks up in this fashion, so these two could be 5. There cannot be a 5 here because this looks at it in the knight's form. So that is something which we have to remember. Now, let's see, what else can we get? This 5, so there is a 5 here, 5 here, 5 here. Now this 2, so there cannot be a 2 here, there can be only a 2 or a 2 here. Now, this 2 looks at this square, this 8 looks at this square via knight, so this can be only a 4 or a 6. So let's pen it as 4 or a 6, because we remember that the shaded portion here was an even digit. And this could be these two. Let's put it as 4, 6, and 8, because those are the only even digits that can come here. Now, let's look at this square once again. If this is a 2 or an 8, where else did we say that there could be a 2? Now let's see. We know that the 2s cannot come in these 3 boxes. We know that the 2 cannot come here. Now let's try a 2 here. If there is a 2 here, 2 and 5, 7, and then there has to be an 8. But this cannot be an 8 because this is an 8. So the 2 cannot come here. Same way, 2 cannot come here because this has to be an 8 then, because everything has to total to 15. So the 2s cannot come here. Now the 2 can come here or it can come here. Now if this was a 2, then 2 and 5, 7, and then this could be an 8. No question about that. then if this is a 2, this cannot be a 2 because of this 2. So obviously we know that this was not a 2. Now if right, if this is a 2, then this could be an 8 here. That could be a possibility, a very strong possibility, which would be there. But then in that sense, let me see. How will the 8 settle? Now, if that is an 8, now let's see this. If this 2 and 8 cannot come here because of this, so that means 2 and 8 cannot come here. It means they could come here or here because those are clones of each other. Now, if this was an 8 and this was a 2, then where could the 2 go in this square? This 2, this 2, this 2, it cannot come here. There won't be a 2 here at all. There won't be a 2 here. There won't be a 2 here. So there could be a 2 in either of these two squares. Now, if these two could be a 2, then this would have to be a 2. Now, if there was a 2 here, there cannot be a 2 here because this 2 would look at this 2. And if this 2 would look at this 2, then there would be this 2 here. And then I would have to put a 2 here, then a 2 here because this 2 looks at here. So this 2 would be here, and then there could be a 2 here, here, or here. Now, if there is a 2 here, there can be a 2 here, 2, 2. Then there would be a 2, 2 here. And then there could be a 2 here. Could it be? Something tells me that my 2 cannot be here. It cannot be here at all. So it has to be here. Let's try this assumption that if this is a 2, then this is an 8. So let me go ahead with this possibility. Now, it means either of these 3 could be an 8. If this 3 is an 8, then there would be an 8 here. Now this 8 looks at this and this. So that means only this can be an 8 because this, if I were to put an 8 here, then there's this, I have to put an 8 here because that's a clone. That 8 doesn't match. If I have to put an 8 here, I have to put an 8 here, so it's not possible. So the only possibility is this 8. Now because of this 8, then I have to put an 8 here or here. There cannot be an 8 here because of this 8. Now that being said, 1, 3, 4, 7, 9. Usually with a 5, I think I can only put 1 or a 9. Okay, 1 or a 9. Then what are the possibilities? 6 and 5, 11 and 4. So this could be a 4, 8 and 4. So this could be a 3. So this is a 3, 4 pair, and this is a 6, 7 pair. Right. Now, in this, what we could do is, if I were to put a 1 here, then 2 and 1, 3, and there cannot be a 12 here, naturally. So this has to be a 9. So this is a 1. If this is a 1 and this is a 6, then this has to be a 7. 7 and 5, 12, and 3, 15. 8 and 3, 11, and 4, 15. So 4, 4 and 5, 9, and 6, 15. 2 and 5, 7, and 8, 15. So everything is sitting well so far. 5, 5. So there cannot be a 5 here because of this 5 looking at this in a knight's form. Now let's decipher what are these digits. 1, 4, 6, 9 can come here. Now 1, 4, 6, 9 can come here. Now let me see. Let's look at the central box first. This cannot be a 6, so it can be only a 1, 4, or a 9. Because those are the missing digits, and 6 looks at this via knight's move. Now 1 and 9 are here. So this has to be 1, 4, and 9 because these are clues and clones. So this is 1 and 9. So this has to be a 4. So this has to be a 4. Because 4, 4, 4 is a knight's move away, 4 is here. Now 1, 6, and 9. 1 and 9 both look at here. So this is bound to be a 6. because 1 and 9 look here. Now 1 and 9 are here. If 1 and 9 are here, I have to put 1 or 9 here. Now 1 cannot come here because of this one. So it's a 9. So this is a 9. So this is a 1. So we've done that. 9, 9. And then let's look at this, which is a 999 here, because we don't know which is what here at the moment. Now this is 1. 1 will come here or here. Now if it's here or here, then it can be here or here. Yes, it could be. Now 1 3 what is it? 1 3 1 2 3 7 is missing. So what are the digits that can come here? Is 3 7. This is a 3 or a 7 only, because 1 and 2, look at it, and this is a 3 7, and this has to be a 3 7, but this being a 3, looking at this, so this has to be a 7 and this has to be a 7. Now that being said, 7 7 7 cannot come here because it's a knight's move, so 7 has to sit here because of this 7. Now 1 2, so 2 is here automatically. Normal Sudoku, 2 sits here, 2 sits here, 1 and 3 sit here. Now this is 1 and 3. Now this is a 3 here, so 3 comes here, 1 comes here, 1 comes here. So that being said, the 1 can either come here or here because of this one, looking at this one via knight's move. Now what are the digits missing? 2 5 9. 2 cannot come here, 2 cannot come here, so 2 comes here. 5 or 9. 5 cannot come here, so it has to come here. 9 comes here. Now this is 148. 148, 3 and 6. What is 148? We don't know what is 148, and this could be 3 or 6. 3 cannot come here because of this 3. This is 6 here and this is 3 here. Okay, 2 2. Then 2 could come here. 2 cannot come here, but 2 can come here. So these, either of them could be a 2. Now 5 5. We still don't know how the 5s sit together. Now 7 cannot come here, so the 7 has to come here. Now 567 sits here. Now 5 cannot come here because of this 5. 6 cannot come here because of this 6. So this is bound to be a 7. So the remaining is 5 6 pair. 5 6 pair. And this is 3 4 and 9. Now this is a 4 here, and so this is bound to be a 3 9. This is a 3 4. This cannot be a 3 here. So it's a 4 9. This is a 4 9.
But the main door is
This is a 4 9.
They can't open it.
But the 4 9 here, and this 7 comes here, and this 5 is there. Then this 5 here, 5 5. This could be a 5 as well, because this 5 could be here. Just hold on a second, please. 1 second. Right. Sorry for the interruption. I had to just shut the door. Now, that being said, 5 6 3 4 and 9. So 3 9 comes here. Now let's look at what else can we solve. Okay, this is a 4 6 possibility. Being 2 cannot come here and 8 cannot come here, 6 cannot come here. So this is a 4, because that was an even digit if we remember. Now this cannot be a 3 7 because 7 is already here. This cannot be a 4 6 because that's a 10. So 2 and 8 cannot be there. So it's bound to be a 1 and 9. Now 1 cannot come here. So this is 1 and 9 because that was the cage, forming a total of 10 if you remember. 3 4 and 6 cannot come here. So those are the missing numbers. 3 4 6 8. 3 and 4 both look at it night way. This 6 is there, so this is an 8. So 346 is remaining. So this is 3 6. This is 4 6, and this is 3 6. Now if this is 3 6 and then this is 3 6, that means this is a 4. 4 4. 4 cannot come here. 4 could be either of these two. So to me, there cannot be a 5 here again because of this 5. Now 1 3 6 and 9. This is 1 3 6 and 9. 6 9 and 3 looks here. This is 1 because of the 3. It cannot come because it looks at it in the knight's form. 3 6 69 is simple Sudoku. 3 3 3 simple Sudoku. 69 6 and 9. 9 cannot come here because it looks at a knight in the knight's form. The knight can 9 is either here, either of these two places. Now this is 2 7 and 8. Now 7 looks here, 8 is here. Sorry, 2, 7 and 9 is missing. 2, 7 and 9 are missing. 9 is here, 7 is here. So 2, 7 automatically comes here, 9 comes here. So that takes care of that. And what is this? 2, 5 and 8, right? Now 2, 5 and 8. 2 is here, 5 could be here, and 8 also could be here. So we don't know that. 2, 2 and 8 is here. So this is 5. So this is automatically 8 and this is 2. So that's taken care of that. Now what is missing here? 67. 6 and 7. Normal Sudoku. 3 comes here because that's the missing digit. 3, 4, 9. So 3 cannot come here. 4 could come or a 9 could come. This is a 4 here and a 9 here. So now this is 1, 3 and 4 is missing. So this would be a 1, 3 and 4 is missing in this line. 3 and 4. Sorry, 3 is looking here, but 4 is possible and 1 is possible. So let's see now. Let's look at here now if there is something that we can crack. Yeah, 1, 6 and 8. So this 6 and this 1. So forces an 8 here. So this is 1 and 6. We don't know. This would be 2, 4 and 5. 2 and 5 is already here. So that's taken care of that. Now 4 looks at this and 4 looks at this. So this will be a 4. 8 is already here. So this is an 8 and this is a 1. This is 4, 5 and 7. 5 and 7 is here. We are going normal Sudoku rules. Here. 5, 5. 5 is bound to be here. 6 is bound to be here. 6, 6. 6 cannot come here because of the knight's move. So this is 6. Remember, this was an even digit. So we got that. 2, 6 and 4 have come here. So this was also an even digit. So the missing digit is 8. And this is 4 and 9. So 4 is already here. So 4 comes here. 9 comes here. I think we are on the home stretch. 1 is here. 1 is here. 3 is here. 3 is here. 9 is here. 9, 9, 9. Perfect. 1, 2, 3. 6 is here and 1. So we have completed the Sudoku, and you will see that these two and this was an even digit. This was a cage of 10 totally into that. These were clones exactly of each other. 381, 946, 527. 381, 946, 527. Central box was a magic square. 2 and 5 and 7 and 8. 15, 9 and 5. 14 and 1. 15, 4 and 5. 9 and 6. 15, 7 and 5. 12 and 3. 15. So we've got that magic square in place, and every other digit, every single digit, 1, 7, right from 1 to 9 is in an anti-knight position. There is not a single anti-knight. There is not a single digit which is knights move away from each other. So I hope you enjoyed this puzzle, and if you have any questions, let me know.